So for this example, I'm going to do one more of the area between two curves. And I want to show you this one because these curves actually intersect in 3 places. And so if that happens, I want to show you what you have to do. So we're going to find the area between these two curves of 2x squared and x cubed minus 3x. Again, when we find the area, we use this formula. And again, we have to find the bounds either by setting these two curves equal or graphing them. And we have to figure out which curve is on top in the region that we're looking at. So if you graph this function, if you go to y equals, I'd pause and put these two in, which I already did. And then I did zoom standard, which is usually how we start. So zoom 6. And I get this graph. And if you look, it's kind of a little bit hard to tell here, but you can see like they intersect here, and then you can see this red curve goes up to the blue, so they might intersect again. So I do need to change my window. I can see that again, these are, I only really need to go to like -2 for this one, and then maybe like 4, maybe it will intersect, or 5. And then we need to make the y values higher, so I need to change the y max. So I'm going to make this, let's say, -4. I'll leave this as 10 for now because we're not sure where it intersects. And then I'm going to make my y max, let's say 15. And my y min doesn't have to be that low. So let's try -2 and graph. And this is kind of guess and check a lot of it. And it's still close, but not exactly. So again, I'm going to change my y max, let's say 25. Okay, and so you can see like it intersects here, and it also intersects at these two curves. So what that means is I have 2 different regions, and I need to find the area of this and the area of this region, and then I need to add them together. So with this, you can also find the bounds by setting them equal. And what you'll find is when you factor, you get 3 values. So if I set these equal to each other, and then I move the 2x squared to the other side by subtracting it, and I put it in order, I can first factor out the GCF, which is an x. So that gives me x squared minus 2x minus 3. And then I can factor the x squared minus 2x minus 3. I'm trying to figure out what multiplies to -3 and adds up to -2. So I want the bigger number to be negative. So it would be like -3 and 1 are the only things that multiply to -3. And that would give me -2. And I need -3 to be negative to get the negative. So this is x minus 3 and x plus 1. And so if I set each of these equal to 0, you can see I have 3 bounds. That should be a positive 3, and x equals -1. So I have x equals 0, x equals 3, and x equals -1. So what that means is this curve intersects, these two curves intersect at 3 places. And what that means is that we have 2 regions that are bounded by these 2 curves, but it switches what is on top and what is on bottom. So I have to do 2 different definite integrals and then add them together. So again, you can go to second, trace for calc, do intersect for each one, move your cursor again, and then hit enter 3 times to get them. I'm not going to do all of them since we just found them algebraically, but you could also do that. If I find the second one, I would again move my cursor to where they intersect here, and you can kind of tell that one is probably 0 there, and do that for the third one here where they intersect to get the 3. So what you're going to do is, if I look at from -1 to 0, those are my first 2 intersections, I can see that the red curve, which is this cubic curve, is on top, and the blue curve is below it. And again, you could zoom in if you need to see it a little bit better. So that means for that region, I'm going to have my bounds from -1 to 0, and I'm going to put the, which one did we say was on top? The cubed one. So the x cubed minus 3x, that would be my f of x, minus, then the g of x would be the 2x squared dx. And that would be the first region I would have to do. And then I have to add the second region because these two curves also create this region. And so we want that area as well. So this one starts at 0 and goes to that 3, but now the blue curve is on top. So I'd go from 0 to 3, and then my 2x squared, that's the blue curve, minus the x cubed minus 3x. And then again, you would solve it. Again, you can use your calculator. I just wanted to set it up for you, but I'll use my calculator again just to save time. So if I want to graph or do the integral, I would do math and then number 9. I would do my -1. I did not want to hit enter. Zero. And then x cubed minus 3x minus 2x squared. Okay, and you have to be careful because I do this often, is make sure once you are done with the exponent, you arrow over to get out of the exponent, which I didn't do, and then it puts everything behind it in the exponent. And then we put our dx. So this would be that first region that we're going to find the area. Again, hit math fraction to get it exact. So it's 7/12. And then I'm going to add this area. You could do it like this. You don't have to simplify. But if you don't simplify, you need to make sure you put the parentheses. If not, you can distribute the negative and then type that in. You'll get the same answer either way. So math, number 9, this time we go from 0 to 3. And then again, you could do if I show you the first one, you could do this first one of 2x squared minus, and then if you don't distribute the negative, you would just have to make sure that you put the parentheses. And especially if you have an older calculator, that's a little bit trickier. And you have to close that parentheses for here, because these parentheses are for the whole integral, and then dx. Or if you don't like that, you can distribute the negative and then you don't need to worry about it. So that gives me 11.25. So 45/4. And then to get the total area, you would add those two together. So you would do 7/12 plus 45/4, which is 71/6. So this doesn't come up often, but just in case it shows up somewhere, you can see how to do that type of problem. So let me know if you have any questions.